Welcome back to my channel. I'm Brian Kafke, and I'm continuing my series on Python programming and the more in-depth yet critical things you need to know to be a true Pythonista. So what I want to talk about here is understanding and using object scopes correctly, because most people don't understand this. I didn't for a long time, and then I got a handle on this, and you can too. So what am I talking about with object scopes anyway? Well, really, variables are what you tend to think of the most, but technically functions and classes also fall into this among anything basically you're creating. So what do we need to know about this? Well, first of all, there may be things here you didn't know. I was surprised. I was reading a book. I will show you the book later, but I was like, wow, I didn't know it did this stuff. And if you aren't aware, you could really hit some bizarre bugs that you'd be like, what is going on? And it can be really hard to trace down. That's the number one nightmare of a developer, right? So how does Python find the object when you're looking for it? So you put in a name like I'm looking for X within my program. How does Python figure out where to find that? We're going to talk about that. Now, the danger one is you modify an object and you've actually modified an object which is in another scope accidentally. That's a risk and it ain't good. Generally speaking, you should be kind of okay, but if you're not aware of how things work, this could happen. Secondly, and similar to this a little bit, is you create an object, but that new object you create hides another object, kind of obscures it because you put that object in a closer scope than where Python would search for it. So it says, oh, okay, I'm going to use this. And if you don't know how things working, you could actually do something as bizarre as replacing the built-in open file method with some variable called open. And that ain't good because you'd be like, what is going on with this thing? So let me walk through kind of diagram. I love pictures. I hope you do too, because to me, a picture explains things the best. So I'm going to teach you the LEGB rule. Okay. Kind of like Lego, but with the B at the end, right? So LEGB is the search hierarchy, or where Python will search, starting on the most immediate, which is local, then enclosed or enclosure, and then global, and then the built-in. So let's kind of look at this in my diagram. So when you start coding, you jump in, whether it's in a Jupyter Notebook or just in a Python script, VS Code or something, you start typing things in like this, right? X equal 5, name equal this, and maybe you define a function. You're actually working in the global variable space or the global object space. So the object, there's actually a name for the global object space scope, which is main. Why is it called main? It's called main because when you're working in the topmost script, it is actually associated with a module, and the default name for that outermost script is underscore underscore main underscore underscore. All right. So that's what it is. And you've probably seen programs where you're looking at it and then it says if the name is underscore underscore main underscore underscore, then call some function that will execute the script. Otherwise, it will import it. And the reason for doing that test is so that when it's imported, it's no longer going to be main. It's whatever is importing it is, and it won't run the script, which is a good thing because it might be calling things to call functions within what can also be a Python module. All right. So what we're doing here is imagine at the topmost part of our script or in the shell, if we're in Python just typing in commands, we type in these different things we're creating, these objects. That would be at the highest level, not the highest I'll talk about, but that would be in the G of this thing above the rule. We're actually in the global. Now, the funny thing is, though, what's local, which is the first place Python will look for anything, is going to depend on where that code is executing from. So technically, when you're first in your Python script and you're just coding away, happy as can be, you are also in the global and the local at the same time. Because, wherever you are, there you are. And you're local to yourself, right? So it's always going to be local that way. However, imagine we create a function and we call this function, and inside that function, it creates some variables here and it says x equal 2. Notice the overlap in names here, and b equal 5, and it does a print. And then it has an inner function within itself. So it's a nested function. Well, when we create that new function, the reference to it, like my function here, is in fact in the global space. It knows it's there, but everything internal to that function is a new namespace or a new area for variables and objects, right? So it's going to create things in there, and they are not visible to the outer level, the higher level. So global cannot see into the function and what variables it has, which is good for us because you certainly wouldn't want your global level script to be mucking about and changing variables and objects which are supposed to be hidden inside your functions, because that would cause all kinds of bugs. However, key thing, the function itself can read, I should say, variables which are in a higher level scope. So in this case, we created my function. My function can see the objects that are in the global scope. Okay. However, if we assign a value, and I'm going to go demonstrate this, no fear, but if we assign a value, right, like x equal 2, it's going to automatically create a new variable in the function scope, which is what it will look at from that point forward, right? It's going to say, oh, you declared x, so I'm going to assume any references in this function to x are not trying to refer to the global variable x, but to what's been defined in the function. That's really important. Now, if I didn't declare a value for x and I just used x, then in fact, it's going to look for, say, like it's like a path search you see in Windows or something, it's looking for a path. So if it doesn't see it locally, then when it's just reading it, it will look at a higher level. So key thing is here, assignment will always declare a local version of a variable or object, but a reading will just look at for whatever the closest matching name is, right? And within the scope levels. And I've got this yellow arrow on the left here to point out that it's always looking from the innermost scope outward. So my function here is going to assign a value to x, so it's going to create a local version of the x variable. B is 5, it's a brand new variable being created. P1 and P2, imagine those are parameters, right? You can see here being passed in. When you pass parameters in, it automatically will create local variables specific to that function. So when people are passing things into it, those are going to be local variables to your function. Now we see that within my function, I have a nested function here, inner, right? So def inner. And def inner has x and b, and we'll assume that it's just reading x and b. Well, because it's just reading them in the inner function, it can just see them, and it will get them from the enclosing function, which is my function. Closing is a little weird thing because you can nest things. So wherever you are in the nest, the next level out, or pretty much any levels out, become enclosing. But generally, the next level from my inner is the enclosing. So in this case, you have an inner function, which is nested within my function. So my function is the enclosing function, enclosing scope. So when it looks for things, the first thing when it looks for this variable x, it's going to say, oh, I don't have it declared within inner. Oh, I can see it's over here, x equal 2, my function. Now, will it go out even further and look for the global? No, it found it. It found it in the closest scope to it, right? So it won't go any further. It stops, just like path searches. I like that analogy myself because I think it kind of makes you see what it's doing. It's trying to find a match for you. And be aware that our functions can reference, as I said, global and other types of variable scopes, but it's not necessarily good practice. And I'll talk a little about that later because the problem is you may not know where is it getting the value for x or b. If you've got 20,000 lines in a program, it may not be that clear. So general rule is try to pass any parameters you want to be seen as parameters explicitly. Python says explicit is better than implicit because it's more understandable. Now back to our story. You can see inner is creating a new variable, new var called something. Each inner scope can read the objects in higher level scopes. If the same object name is assigned a value in a lower scope, it creates a new object in that lower scope, and that will mask or hide the object in the higher level scope. So it's something to be really careful of because that's where you can get some bugs if you're not expecting that. Unless you use the global or non-local keywords, I'll talk about this a little bit more, then this is the way it's going to work. There's a way to kind of override this behavior so you can get more control if you want, but this is how it will work by default. Now modules, I haven't even talked about yet, and they're kind of outside of this whole thing. Modules get their own namespace if, and only if, you import them with like the import pandas, right? You say import pandas as PD. You notice you always have to prefix everything with PD because PD becomes the namespace, the name of the namespace that you're working in. If you just said import pandas, then you'd have to prefix any references to objects within the pandas library with pandas dot. So the PD part is just, when you see that, the as, you're just giving it a short alias to make it easier for you. Now, if you do the from pandas import type of syntax, which we see all over the place, be a little bit careful because that's actually copying those things into the global namespace. You can trample on other global objects if you're not careful. So we can see what we have here. We have the local, which is happens to be wherever you are. So if you were actually in inner, then the local scope is where inner is. But if you were in my function, local would be within the my function. Now, if it can't find a variable in the local scope, then it will look at the enclosing scope. So inner says, I don't see it here. It will go to my function, the enclosing scope, then the global scope. And then it will look at one other place, if I have it here. It will look at built-ins. I didn't mention this yet because I never think much about built-ins, but you notice you get into Python and you have things like open method available, or open function. You also have print and all kinds of stuff in the built-ins. So built-ins are the last place that it will look. So it's going to go through local, enclosing, global. Can't find it there, it will look in the built-ins. Now, the only thing you have to be careful with built-ins is if you happen to create a local object that is the same name as the built-ins, then you're going to get into the problem where you could be masking it. Like imagine you create a variable called open, and then you try to open files, and you're like, gosh, this isn't working. It's giving me errors because you've overlaid, you essentially replaced the built-in open file statement, say, with your own. Sometimes you may want that, but I would be very careful about that, and I would personally avoid doing that at almost all the time because you can really confuse yourself, and you don't want to do that. All right, so we're going to go through a nice demo here with all our cool stuff. And I've already talked about some of this. We talked about scoping. This book right here is called Learning Python. I really like it. It is a really thick book, and it isn't something that you can keep your eyes open all the time through. Author's great. Mark Lutz, love the book. Get the latest version you can, but I got it on, I actually do it as an ebook on Amazon, pulled it down, and I read bits and pieces every night to get more and more because he really does a great job of digging into the nuances and how Python's really built architecturally. And you need to know that if you're going to really be a good Python developer. And I included this. This is a link you can go to. And this is what I copied as an image out of it. But it kind of goes through all these different scopes I mentioned. So local or function scope, enclosing or non-local, it's sometimes called scope, global, and then finally built-in. So let's start looking at the code because the code's fun. And by the way, you can get this notebook for your very own by following a link in the description. It'll take you to my GitHub account and you can have this brilliant notebook. You're going to love it. So the dir command is pretty cool because the dir command will let us take a look at different modules. What's in there? And the dir built-ins will show me what's in the built-ins. So you can see a lot of it. It's all these warning messages that we know and love. It's got all kinds of stuff in here. And then it gets into different object types, dictionaries, all kinds of stuff in here. And you can step through there. It's quite riveting, but understand that's kind of the underlying Python language and it's got its own things it uses. So be a little careful. You may not want to call, for instance, your own function type because you may get some trouble there. To get another look at this, we can actually import built-ins because in the end, it seems in Python, everything is created as a module and it's understood by Python as a module. So not surprisingly, the built-ins are a module. We don't have to import them because by default, they're in the global namespace for us. But we can, for example, here, import built-ins as BI, and then I can just say BI length and directly reference them. So what I've really done is create a copy of what's in the built-ins into a different scope, which is now under the BI. Now, if I create variables right in my script, this is a Jupyter Notebook, but it could just as easily be any script, really. I'm creating two variables here, my global var1 and my global var2. I run that, and then I'm going to take a look at that, but that is in the global scope. Now, you can use dir to give you a list of scope variables. You can also use globals for the global level, but the weird thing I find with globals is it just gives you everything, including like history of what you're doing, and it just gets to be unwieldy. So I'll show you other ways to do it. And if you do locals function, just run locals, it will give you what's in your local scope, which is wherever you're sitting. So right now, if I did locals, it's going to show me everything sitting in the global namespace. So if I just try dir here, without anything, I should see all the cool stuff. This is giving me the global namespace as well. You can see my two variables there are showing up. So we know that's the global space. Another way we can do something is if we want to look through the globals, as I mentioned, gives you way too much. I kind of put together this little hack where I'm going to take globals and fortunately it returns a dictionary. So I'm going to put it in global dict and then I'm going to loop through it and just return variable names again to show you what's there. And we can see by doing that, it again tells me this is what's in my global space. So those are some cool tricks. And as I mentioned, I can just say locals and you get all this stuff too. Unfortunately, it gives you an awful lot of stuff. But somewhere in here, you will see Yeah, you can see it here also, global variables. Not a big fan of that one though, because it's an awful lot of stuff you got to look through, right? So we know we're in the global scope. Now I'm going to create a function which will exist in the global scope, but this function is creating its own variable. Function underscore var1 is assigning a value of 1. Variables in the function local scope, and I'll just do locals, and we should see this showing up. Now, why is this going to be different? Because I'm running the local statement from within my function. So in that context, it's going to show me all the variables within that function scope. And here I'm just going to call my function, pass it in, pass the string something as a parameter. We can see the parameter it takes is in1 colon, and the type is string. By the way, this is a type hint. It's not enforced, but the idea of a type hint is when someone's reading a code, they can see, what type of parameter is expected. It's also good for different types of tools that may be used in development to kind of check things for you and avoid errors. All right, let me run this. This statement ran, as I said. We can see variables in the function scope in1 because that is a variable created. Parameters are automatic variables in the function, and then function var1, we can see it there. So hey, we now see a function level scope, which is a subscope within the global scope. Let's print var1 and var2, and we can see that these haven't been impacted. We haven't really done anything here, so nothing's changed with those. Let's try something else though. We're going to create another function, my function. We're not declaring any parameters for it, but as we learned already, we can see variables in the higher level scopes. So we can see the global scope here. So I'm going to just prove that by printing it. And then I'm going to create another my global var2, and I'll say it's equal to test, and then I'll do my function here. So what I'm doing here is I'm creating a brand new variable, even though it has the same name as a variable in my global scope. I'm creating a new one because when I assign, creates local scope variables. Always, unless I use a special statement to override that, that's what it will do. But when I just read, it will look to whatever scope applies. So since I don't have my global underscore var1 in this particular function, in other words, I haven't declared it, it will look to the global scope. So let's run it. So after we ran this, it did the print statement, and we see that my global var1 has a value of 2. But what is the value of my global var2? Because remember, we assigned a value in our function. Did it keep that value, or did it keep the original value? This is proof that you're not going to alter the value of objects that are at a higher level scope. In other words, when we assign a value of an object, it will create it at the local scope level. And we can see here, even though we put a value of test in there, once we get outside that function, it's going to go back to its old value because it actually had two different copies of the variable, one in the function scope, one in the global scope. Now let me ask you a question, Brian. What happened to my global var2? Where'd it go? What happened? Functions are an interesting thing. When you call the function, it creates whatever object it needs in memory and all the variables needed to support it. And once it's done, it goes away, like the Cadbury Easter eggs. And the function's gone, it's gone. So it disappears. And this is true of classes or anything else if you clear them out. Okay. I want to show you something interesting. This time in my function, we're going to do two things. We're going to do print my global var1 as we did before, but then we're going to assign that a new value. Now you might think, okay, that's not a problem. What I would expect to happen, this is where it gets a little nuanced, I would expect it's going to show me what's in the global scope here. And then I would expect it to create a local scope after that if I refer to it further down, I'll see that value. But that ain't what it does. Let's see what happens. It gives us an error. So here it says local variable my global var1 is referenced before the assignment. So what Python actually does is it looks at the entire function and it says, oh, I see you're creating a new local variable. Then what are you doing here? This should not happen until after you've assigned it a value. You cannot alter within the function the scopes. In other words, you can't have it at one point in the function global and at another point in the function a local variable the same name. Python doesn't let you do that. It's kind of scanning ahead and determines what you're doing. So something like this would fail. Now the way to solve it is to do something more like this. assign the value first, and then do the print. All right. But this, I have to be honest, this looks to me like a really hard to find bug just waiting to happen. I can really easily see that happening. So just be aware of that. Now let's talk about enclosing scopes, right? So we've got this outer function, we have an inner function, and we're going to call the inner function from within, the overall outer function function. That's not confusing. We're going to create an outer function var1, some value. Then we're going to print out locals so we can see it. Then we're going to declare an inner function, and we're going to print locals to inner function, and we'll do locals again. Then we're going to call the inner function, which will run this. And this is all going to happen within this general function. And we're going to pass into this function 2 parameters, right? And we're just passing 2 strings, could be anything. And when we run this, we can see that when it ran the outer locals function, it shows us everything sitting there, which is all the variables, the parameters, as well as the outer function var1. Locals here has nothing local to it, right? Now, if we run the same thing again, and I found this kind of interesting, I didn't expect this myself, but I'm running the same basic thing, but here I'm going to be printing the outer function variable outer function var1, and then I'll do the locals. And what's interesting here is it made a copy of the outer function var1 simply because I printed it. So it must do something where it's copying variables down when you do those kind of references, which may also be why it doesn't like to do it midstream. Now we have another function version of outer function. Outer function, same parameters. And say outer function var1 is before, print locals. Here we're going to declare on the inner level outer function var1 and give it a new value. We're going to also create something which is the same name variable as our parameter first above. Then we're going to print the value of the outer function var1, which should be this, right? And then we're going to do the locals. Then we'll call the inner function. And then after, still within our call, we're going to print out the outer function var1 in the parent function, right? The outer function, the enclosing function to be specific. And then we'll do this first parameter, which is the parameter itself. Now, the question for this is, will it keep the value that was assigned in the inner function, or will it go back to what was in the outer function? So let's run it. And you can see that we've got locals to the outer function when we began. Variables in the inner function shows new value because that was assigned, right? Local values, local variables to the inner function, new value, and first. So this, we can see these were reassigned as we expected. But now we're going to be running these statements, which are in the outer scope. And we can see in the outer scope, it went back to some value and first parm. So it's right back to where it started. Again, the inner function temporarily created some variables, did its work, and then cleared out. So even within a nested function, the inner functions will clear out when they're not in use. And just to see, did we mess around with the overall global function yet? Nope, we're still back to where we were. All right. So you might say, well, Brian, I got a question. Suppose I'm in an inner function, I'm at some other scope level, and I want to change a different scope. I want to go and change the global. Can you do it? Yes, you can. Let's see. I feel like Bob the Builder here, if you know that reference. So we're going to create an outer function here, and I'm going to say enclosing variable outer function, and then I'm going to create an inner function. And there's a few things I want to show you here. First of all, there's this global keyword. Very cool. What global does, it says, I know what I'm doing, and I want to point to the global variable, my global var1. So I'm creating, and this is one of the few cases in Python you've heard, you don't declare variables before using them, except, this is a good thing if you're in an interview, say, but, because they'll be like, wow, I didn't know that. When you want to refer to a different scope, you do declare it first. You do a reference to it. Now, this should replace the value in my global scope. The non-local should really probably be called enclosing. Non-local means that I'm referring to a variable, I'm declaring that variable in the outer scope, the immediately outer scope to this function. And once I've done that, I can change that, and I'm going to say inner function, right? It was outer, it's going to say inner. Then I'm going to say first is equal to new first, which should not really stay. I didn't do any special declarations, so that shouldn't change anything. Then I'm going to see what the local scope looks like here. But then I want to take a look what's going on here. Do this. Oh, and then once I'm outside the inner function, let's see what the global variable shows, but also what the enclosing variable shows. Did it keep those values? Inquiring minds want to know. And we can see that we did our local inner functions here. Great. global variable shows a new value, and enclosing variable after the function call says inner function. So yeah, it actually kept it. And I can even test it here at the global scope. It actually reached out and changed the variable in the global scope. So these are rare use cases where you might find you want to do stuff like this, but make sure you carefully document it. It's very obvious to people. And if you're doing something, I mean, I can imagine you sharing a variable. It could be like a counter or something. You want to reference it. Not a bad idea, but try to create names for them that are like, nobody would create something like XYZ purple, whatever. So nobody can accidentally trample on it or get confused. It's very clear what you're doing. Okay, finally, and this is exciting too, right? Everything's exciting. So I mentioned, as we saw, we have module namespaces. So current module, if I wanted just to prove that I'm not lying, the current module of the script is. So that's why, as I said, we're actually, the global scope, what we're doing within this notebook is actually in the main module. By default, Python just does that. If I import a module name or import a module name and give it an alias, either way, it's pretty much the same thing, like import pandas as PD, then I can then do dir and it will show me what's going on within that namespace. You see, there's a lot there. And that's one of the reasons why doing that format of an import is a really good idea. And I'm glad Pandas has standardized on that. An alternative you can do, say, from Pandas, import read CSV. Now, the problem with it is it's bringing in the read CSV into the global namespace here. Why is that a problem, Brian? Well, suppose I created something called read CSV as my own function because I had some special things I want to do. Well, depending on the order, if I had already imported Pandas and I think I'm using that, then all of a sudden I'm getting this other function, and that can be really hard to debug. I've done it before, it ain't pretty. So you don't want to do that. You want to make sure that, I really like to make sure whatever is my own custom code is clear. Sometimes I'll just put a special prefix like BPC, my initials or something, but something that makes my code separate from like built-in or open source library code so I don't get confused. You may want to do something like, replace that, but I would be very careful. Now, the standard of using like import pandas as PD is great because you always say PD before something. There are times when doing the from, we do this in Databricks a lot. From library import, like I showed you above, from library do something, that can get you into trouble. So this is okay, but if you're doing a lot of different libraries, a lot of modules and functions and objects, be careful. You can get yourself tripped up pretty easily there. And to prove that point, I'm going to declare my own little function here, read CSV. And look what happens when I try to call it. Okay, it worked, but suppose I really wanted to read a CSV file. Can't do it anymore. And can you imagine, you got 3 million lines of code and there's all kinds of stuff going on. You're just trying to do a simple little Python read and like, wow, it won't work. So not a good thing there. All right, so let's quickly review the takeaways here. Each inner scope can read the objects of higher level scopes. We saw that over and over in here. If the same object name, right, is assigned a value in a lower scope, it will mask or hide the higher level scope by creating a local scope of the same name. So while you're in that scope, it ain't going to see what's in the higher level scopes. So you do have to be careful. That can be great, but it can also cause confusion and bugs. Modules get their own namespaces, right? And so that's a nice way to keep from trampling on each other. To change the global variable from within a lower level scope, then you can use the global keyword. That way, Python knows you know what you're doing. And to change something in an enclosing scope, you can use the non-local keyword. So I want to thank you. Please like, share, subscribe, yada, 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 all that stuff I always say. But, I hope this helped. Put comments in if it helped you. I always like to see that. I know it's good. If you have questions, do that. I'm not done yet. I'm going to do more of this stuff. And I'll be honest, it isn't necessarily the most exciting things. You'd rather be copying, trillion gigabyte rows of data or something, but you really need this. It's important because you want to build out, and don't be a hack of a data engineer, Python programmer. It's easy to do that. I'm tempted to do it, but you want to get to be good at it. Don't just be like that. I think the best Python programmers are probably more the app dev people. Data engineers like me, we tend to get lazy and just get it to work. But we really need to leverage the language better, and that's why I'm doing this series. Till next time, thank you.